What is bromine? Bromine, BCDMH, is a stabilized organic compound that comes in granular form or tubs. It has 27% available chlorine and 95.5% active strength. In a 1% solution, it lowers the pH to 4.8. Bromine is a generic term for any chemical that releases hypobromous acid when dissolved in water. It is a halogen similar to chlorine, and it is used as a disinfectant due to its good algicidal properties and oxidizing ability. However, elemental bromine is not used as a disinfectant. Instead, compounds that release bromine or hypobromous acid are used. Bromine is more stable than unstabilized chlorine at high temperatures, making it a popular choice for spas and hot tubs. What are the chemical properties of bromine? Bromine is a halogen that releases hypobromous acid when dissolved in water. It is an oxidizer and reacts with water to produce hypobromous acid, which then dissociates into hydrogen and hypobromite ion. Bromine also reacts with ammonia in water to form monobromine, dibromine, and nitrogen tribromide. When bromine-releasing chemicals dissolve in water, they form hypobromous acid, hypobromine ion, and hydrogen ion. The relative percentage of hypobromous acid and hypobromine ion depends on the water's pH value. Bromine is also a highly reactive chemical that reacts with common inorganic compound and organic matter to form bromo-organic compounds. Sunlight destroys bromine similarly to hypochlorous acid. What is the composition of bromine? Bromine is a halogen similar to chlorine, iodine, and fluorine. It is a heavy reddish-brown liquid that reacts with water to produce hypobromous acid, HOBr. Bromine is also a part of various compounds such as sodium bromide, a salt of bromine, and 1-bromo-trichloro 5.5 dimethyl hydantoin, BCDMH, an organic substance with chlorine and bromine attached to the organic carrier molecule, dimethyl hydantoin, DMH. Is bromine stable? No, bromine is not stable. It can be stabilized, making it expensive. However, bromine is more stable than unstabilized chlorine at high temperatures. Despite this, stabilized chlorine is more effective and cheaper. Bromine is typically used by those who frequently use their spas and dislike the smell of chlorine. How is bromine produced? Bromine is produced through two main methods. The first method involves adding sodium bromide, a salt of bromine, to water, and then adding an oxidizer which converts the bromide into hypobromous acid. The second method involves using bromine tablets which dissolve and hydrolyze to make hypobromous acid. Another type of bromine tablet that does not contain any chlorine is also used, but it requires a separate oxidizer to regenerate the bromine ions. How is bromine sold? Bromine is sold in two main forms, 2-part bromine and bromine tablets. 2-part bromine involves a system where sodium bromide, a salt of bromine, is added to water and then an oxidizer is added. Bromine tablets, or 1-bromo-trichloro 5.5 dimethyl hydantoin, BCDMH, are placed in a brominator. Another type of bromine tablet is 1.3-dibromo 5.5 dimethyl hydantoin, DBDMH. Both types of bromine tablets are acidic and should be placed in a brominator, not in the skimmer. What are the different types of bromine products? The different types of bromine products are 2-part bromine and bromine tablets. 2-part bromine is a system where sodium bromine, a salt of bromine, is added to water and then an oxidizer is added, converting the bromide into hypobromous acid. Bromine tablets, or 1-bromo-trichloro 5.5 dimethyl hydantoin, BCDMH, are placed in a brominator where they dissolve and hydrolyze to make hypobromous acid. Another type of bromine tablet is 1.3-dibromo 5.5 dimethyl hydantoin, DBDMH, which does not contain any chlorine and is truly chlorine-free. What are bromine tablets? BCDMH, 1-bromo-trichloro 5.5 dimethyl hydantoin, BCDMH, C5HGN20 greater than CLBr, is an organic substance with chlorine and bromine attached to the organic carrier molecule, dimethyl hydantoin, DMH. As BCDMH dissolves into water, HOCl and HOBr are formed along with organic DMH. BCDMH is available as sticks, tablets, or granules. It is a NFPA class 2 oxidizer, indicating that it moderately increases the burning rate of combustible materials it contacts. What is a bromine feeder? A bromine feeder is a chemical feeder designed specifically to dissolve chemicals that release hypobromous acid into water. How to apply bromine? Bromine can be applied using bromine tablets, which should be placed in a brominator, not in the skimmer. These tablets require more water flow to dissolve than trichlor tabs, so a trichlor chlorinator should not be used to feed bromine tubs. Regular monitoring of the pH and total alkalinity is necessary due to their acidity. Another way to apply bromine is through a two-part bromine system where sodium bromide, a salt of bromine, is added to water. An oxidizer is then added, converting the bromide into hypobromous acid. How can you test bromine? You can test bromine by using standard chlorine test procedures. Multiply the observed free chlorine levels by 2.25 to determine total bromine levels in a sample known to contain bromine. Many test kit manufacturers provide the bromine calibration on the test block comparator. Bromamines react with DPD number 1 and DPD number 2 similarly to hypobromous and hypochlorous acids, meaning you cannot distinguish combined bromine from free bromine. Therefore, you only test for the total bromine residual. Where is bromine used? Bromine is used as a disinfectant in spas and hot tubs. It is also used in indoor pools and in high-use applications. What are the benefits of bromine? Bromine as a halogen is an effective oxidizer and disinfectant with good algicidal properties. It is also stable. It is also more stable than unstabilized chlorine at high temperatures, making it a popular choice for spas and hot tubs. Bromine is less irritating to mucous membranes than chloramines, making it suitable for high-use applications. It also doesn't have the strong smell associated with chlorine, which some people find unpleasant. Bromine can be recycled in the water by adding an oxidizer, which converts bromine ions back into hypobromous acid. What are the properties and uses of bromine releasing chemical? Bromine releasing chemicals are less irritating to mucous membranes than chloramines, making them popular for high-use applications like spas. Although they are oxidizers, they are not as potent as chlorine. It's common to periodically oxidize bromine-treated pools or spas with a chlorine or non-chlorine oxidizer. This process forms bromine ions, BrAO, which react with oxidizers to create hypobromous acid. What happens when bromine is added to water? When bromine is added to water, it reacts to produce hypobromous acid, HOBr, which is the killing form of bromine. This acid then dissociates into hydrogen and hypobromide ion, a reversible reaction that maintains equilibrium. Initially, bromine reacts with common inorganic compounds with no disinfection occurring. As more bromine is added, it reacts with ammonia and organic matter to form bromo-organic compounds, which disinfect but more slowly than HOBr. These initial reactions contribute to the water's bromine demand. Once met, further bromine addition builds up the residual needed for disinfection. How does bromine react with ammonia? Bromine reacts with ammonia in water to form monobromamine, dibromamine, and nitrogen tribromide. Organic amines will produce organic bromamines. Bromamines are excellent disinfectants with less odor and are less irritating to the eyes. Bromine, like chlorine, is a highly reactive chemical that can react with ammonia and other organic matter to form bromo-organic compounds. These compounds act as disinfectants, although they work more slowly than hypobromous acid, HOBr. This reaction with ammonia and organic matter contributes to the water's bromine demand. Once this demand is met, further addition of bromine builds up the residual needed for disinfection. What are the compatibility considerations for bromine? The compatibility consideration for bromine include its reactivity with other chemicals, its stability at high temperatures, and its acidity. Bromine is a highly reactive chemical and can react with common inorganic compounds, ammonia, and organic matter. It is more stable than unstabilized chlorine at high temperatures, making it a popular choice for spas and hot tubs. However, bromine tablets are acidic and should be placed in a brominator, not in the skimmer. They require more water flow to dissolve than trichlor tabs, so a trichlor chlorinator should not be used to feed bromine tabs. Regular monitoring of the pH and total alkalinity is necessary due to their acidity. Incompatible chemicals with bromine can release chlorine gas, hence an emergency response plan should be in place. What are bromine residuals? Bromine residuals refer to the amount of bromine that remains in the water after its demand has been satisfied. Unlike chlorine, which has several types of residual, only total bromine matters for bromine. This is because bromine is 2.25 times heavier than chlorine, requiring 2.25 times as much to achieve the same effect. What factors influence bromine residuals? Several factors affect bromine residuals. Sunlight, UV rays degrade bromine with a 65% loss in just 2 hours. Algae consumes large amounts of bromine. Rain, smoke, pollen, and pollutants are introduced into the water. Heat and aeration, water temperatures above 92 degrees Fahrenheit double bromine's activity, using it up faster. Swimmers and bathers, they introduce sweat, urine, feces, personal care chemicals, and bacteria into the water. What is the oxidation problem with bromine? Bromine cannot oxidize swimmer waste and organic like sweat, urine, and cosmetics. There's no test for these contaminants, so you must estimate when to add a chlorine or non-chlorine oxidizer. Heavily used spas may need an oxidizer after each use. The two most common oxidizers are chlorine or MPS, potassium monopersulfate. How to increase chloride in the pool with bromine? Increasing chlorine in the pool with bromine is not possible. Bromine and chlorine are two different types of sanitizers that are used in pools and cannot be used interchangeably. How does bromine compare to chlorine? Like chlorine, bromine creates a balance between hypobromous acid HOBr and hypobromite ion OBr. HOBr is more effective at killing microorganisms. Hypobromous acid is a weaker acid than hypochlorous acid, so at a similar pH there is more hypobromous acid and less hypobromite. For instance, at a pH of 7.5, about 94% of the total bromine in the water is HOBr and only 6% is hypobromite. The difference in chemistry has led to bromine disinfectants being widely used in spas, which typically have a higher pH. How does sunlight affect bromine? Sunlight destroys HOBr similarly to HOCl. About half of bromine can be destroyed by sunlight in 60 to 90 minutes. Cyanuric acid does not protect HOBr from ultraviolet sunlight destruction. Once a brominating product is used, bromine will remain in the water. Adding a stronger oxidizer like a chlorinating chemical will cause the bromide to be oxidized to hypobromous acid, consuming the hypochlorous acid. Therefore, cyanuric acid no longer stabilizes the chlorine once bromine has been used, as hypobromous acid will be present instead of hypochlorous acid. How does UV light affect bromine? UV light can be used for disinfection and combined chlorine removal. However, it can also destroy free chlorine in water. UV kills most organisms with the risk, light intensity, and exposure time. With the right light intensity and exposure time. It doesn't oxidize swimmer waste and organic contaminants, and it is only effective within a few inches of the bulb.